Good morning, students. Today we are going to read the second lecture in the topic of permutation and combination in the subject of probability and statistics 1 in A levels. So concentrate yourself. We are going to start now and we will practice different kinds of the question to take grip on this topic. So the first question which we are going to do is today, that is, in how many different ways can 5 boys be arranged in a row? So if this kind of the question comes in the paper, so the method to solve this kind of the question will be 5p5, because in how many different ways can 5 boys be arranged in a row? So 5p5, so 5 factorial, and when you will solve this 5 factorial on the calculator, you will get the answer, that is 120. Another question is here, in how many ways can 9 elephants and 4 mice be arranged in a line? So 9 elephants and 4 mice be arranged in a line. So look now, the 9 elephants and the 4 mice are distinct. So we are arranging 13 different animals. So the method will be 13p13. So when you will solve it on the calculator, you will get this answer. Here is another very important question. The statement is, the capital of Burkina Faso is, find the number of the distinct arrangements of all the letters in this word. So look now, there are identical letters in the word. So the formula which we have learned, which we have read in the lecture number 1 will be used here too. So look now, 11 letters. So here are 11 letters: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And requirement is find the number of the distinct arrangements of all the letters in the word. So 11 letters are to be arranged with repeats of 3 O's. So there are 1, 2, and 3 O's, 3 U's, 1, 2, and 3, and 2 A's, 1, 2 A's, and 2 G's. So 1 and 2 are G's. So the method to solve this kind of the question is, the number of the letters are 11. So 11 factorial will be put in the numerator, and then the identical terms, the number of the identical terms will be put in the denominator. So look now, 3 O's, so 3 factorial, 3 U's, so again 3 factorial, 2 A's, so multiply by 2 factorial, and 2 G's, so multiply by 2 factorial. And when you will solve it on the calculator, you will get this answer. Here is another question, very important. So concentrate yourself. Find the number of the ways of arranging 6 men in a line so that A part is, the oldest man is at the far left side. So look now, you have to make your concepts clear and you have to understand it. And look now, without restriction, these 6 men can be arranged in 6p6, that is 6 factorial, 720 ways will be the answer. So with restriction, there will be fewer than 720 arrangements. So look now, because there are restrictions, A part's restriction is, the oldest man is at the far left side. So it means out of 6 men, 1 is the oldest man. So that should be placed at the far left hand. So look now, here is the oldest man, that is placed at the far left end. So 5 men will be left now, and there is no restriction for the remaining 5 men. So 5p5. So now you will solve it on the calculator. That will give you answer 120 arrangements. B part's restriction is, the 2 youngest men are at the far right end. So 2 youngest men will be placed at the far right end. So these 2 places will be for the youngest man. So it means remaining 3 places will be left. In total, sorry, there are 6 men. So 2 places at the far right end will be for the youngest man, and 4 places will be filled with any other arrangement. So look now, 2p2, that is at the far right end for the youngest people, and remaining four places on the left side will be filled in any way, so 4p4. And when you will solve it on the calculator, you will get this answer 48 arrangements. C part's restriction is the shortest man is at neither end of the line. So the condition is the shortest man should not be placed at the far left or far right end. So how many arrangements can be made? So look now. So, because the shortest span is to be placed between the extreme left and the extreme right, so it means there are five people we have in a choice to be placed at the left or the right side, and after that, four persons will be left to be placed on the other side. So look now, if we have five choices of the persons to be placed and on the extreme left, and after that four choices will be left to be placed on the right, because the shortest span is to be placed in between of it. So after placing extreme left and extreme right, there will be left four persons which are to be arranged in any way. So 4p4. So look now, 5 into 4p4 into 4, that is this one, 5 into 4p4 into 4. And when you will solve it on the calculator, you will get this answer, 480 arrangements. Here is another very important question. So look now, how many odd 4-digit numbers greater than 3000 can be made from the digits 1, 2, 3 and 4, each used once? So here is a condition. Odd numbers, that is 4-digit number greater than 3000, can be made from these numbers, and these numbers are used once. So look now, greater than 3000 means the numbers will be started with 3, will start from 3 or 4 to make number greater than 3000. So start with 3. If we place 3 at the extreme left, then there will be 3 choices left for the remaining 3 digits, but we have to make odd numbers. So for making odd numbers, only 1 is the number that should be placed at the extreme right. So look now, 3 is placed at the extreme left and 1 will be placed at the extreme right, and then there will be 2 and 4. So there are 2 digits left for these two positions. So 2p2. So 1 into 2p2 into 1 will give you answer 2 numbers. Okay, here is another choice, that if we start the number with 4, because starting with 4, the numbers can also be made greater than 3000. So if 4 is placed at the extreme left, then to make the odd numbers 1 and 3, we have 2 choices to be placed and on the extreme right. So look now, 4 is placed on the left, so 2 choices are left for making the odd numbers 1 and 3. So 2 choices on the extreme right. So when this will be done, then we will left 2 numbers to be placed between these 2 extreme positions. So 2p2. So 1 into 2p2 into 2 will give you answer 4 numbers. So then finally we will add these 2 cases. So 2 numbers plus 4 numbers will make 6. Odd numbers greater than 3000 can be made from the digits 1, 2, 3 and 4, each used once. And other question is here, how many 3-digit numbers can be made from these 7 digits 3, 4, 5, 6, 7, 8 and 9 if each is used at most once? So look now, we select and arrange just 3 of these 7 distinct digits. So 7p3, the formula for solving 7p3, so you can solve it directly on the calculator, or here is a step. So 7 factorial over 7 minus 3 factorial, and when you will solve it on the calculator, this will be the answer, that is 210 3-digit numbers. Here is another question, in how many ways can 5 playing cards from a standard deck of 52 cards be arranged in a row? So the simple method is we select and arrange 5 of the 52 playing cards and ignore 47 of them. So 52 P5. You can solve it directly on the calculator, or you can make an other step and then you will solve it. This can be solved directly on the calculator, that is 52 P5. So answer will be this one. Here is another question. In how many ways can 4 out of 18 girls sit on a 4-seat sofa when the oldest girl must be given one of the seats? So it means it is condition that the oldest girl must be given one of these seats. So there are 4 choices for the oldest girl to sit on any seat of the sofa. So look now, there are 4 options. So look now, 4 ways for the oldest girl to occupy a seat. So 4 multiplied by. Okay, after sitting of the oldest girl, there will be left 17 girls and 3 girls will be chosen from these 17 girls. So 17P3. So these 3 girls can be chosen in any way. So look now, and 17P3 ways to select and arrange 3 of the remaining 17 girls to sit with her. So 4 into 17P3 is equal to, when you will solve it on the calculator, this will be the answer. Here is another very important question regarding your syllabus, regarding your paper. So concentrate yourself. In how many ways can 4 boys and 3 girls stand in a row when no 2 girls are allowed to stand next to each other? So it means there is no condition for the boys. Boys can be arranged in any way. So look now, 4P4 ways to arrange the 4 boys in a row. So 4P4. But the condition is no 2 girls are to be allowed to stand next to each other. So look now, there should be spaces between the boys. So girls can be placed here, 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 or here. So this is the way, because of which no 2 girls will be stand next to each other. So it means there are 5 places in which 3 girls are to be stand. So look now, 5P3 ways to select 3 of the 5 spaces between or to the side of the boys and arrange the 3 girls in them as shown. So arrange the girls in 3 of these 5 spaces, that is 5P3. So 4P4 into 5P3. So when you will solve it on the calculator, the answer will be 1440 ways. Here is another question. And from here, some questions will be of combinations that are going to be solved. So look now, the statement is, in how many ways can 3 fish be selected from a bowl containing 7 fish and 2 potatoes? So when this kind of the questions is there, so in a bowl there are 7 fish and 2 potatoes, and in how many ways can 3 fish be selected? So this is a question of the combination. So look now, 7C3, and when you will solve it directly on the calculator, this will give you the answer 35 ways. There is another way to solve the question that will take 1-2 steps more. So 7 factorial over 7 minus 3 factorial into 3 factorial. So this is the way. So when you will solve it, again you will get the same answer. Here is another question. The statement of the question is, in how many ways can 5 books and 3 magazines be selected from 8 books and 6 magazines? So look now, 5 books are to be selected out of 8 books and 3 magazines are to be selected from 6 magazines. So 8C5 into 6C3. So when you will solve it on the calculator, you will get this answer. Here is another very important question. A team of the 5 is to be chosen from 6 women and 5 men. So 6 women and 5 men are available, out of which a team of the 5 is to be chosen, and the condition is, find the number of the possible teams in which there will be more women than men. So this is the condition, more women than men in a team of 5. So look now, we will make different choices. The first case is, so look now, from 6 women and from 5 men. So if all 5 women are to be chosen, and no man is chosen. So this is a case in which more women are there than men. So this will be 6c5 into 5c0. So this will give you the answer on solving it on the calculator will be 6. Here is another case. If 4 women out of 6 are chosen, and definitely to make a team of the 5, 1 man will be chosen from out of the 5. So then 6c4 into 5c1 will give you the answer 75. Here is the last case when 3 women out of the 6 are chosen and 2 men out of the 5 are chosen. So 63 into 5c2 will give you the answer 200. And the answer of making the teams in which more women than men are 200 plus 75 plus 6. So this is the 281 teams with more women than men. Here is another question. How many distinct 3-digit numbers can be made from 5 cards, each with one of the digits 5, 5, 7, 8, and 9 written on it? In this question, you have to be very careful because 5 is repeating 2 times. So look now, the 5 is a repeated digit. So we must investigate 3 situations separately. The first situation is with no 5 selected. So if no 5 is selected, then 3 numbers will be left, out of which we have to make 3-digit number. So this is a very simple case. So 3p3, that will give you answer 6. But when 1 5 is selected, so this is a question in which permutation and combinations are mixed. So look now, if 1 5 is selected, so there will be 3 places because we are going to make 3-digit number. So there will be 3 places for the 5 to be placed. So 3 factorial, and then out of these 3 numbers, 2 will be selected because we are going to make 3-digit numbers. Okay, so 3c2 into 3 factorial. When we will solve it on the calculator, it will give us the answer. Okay, the third and the last case is when 2 5s are selected. So when 2 5s are selected, the method is 3 factorial over 2 factorial, because for the first 5 there will be 3 places, and for the second 5 there will be 2 places. So 3 factorial over 2 factorial, this is the way. And out of these 3 numbers, 1 will be selected now. So 3c1. So when you will solve it on the calculator, this will give you the answer 9. Okay, and finally you will add these 3 answers, 6 plus 18 plus 9. So this is the answer. 3-digit numbers can be made. Here is another question. There are 15 identical tins on a shelf. None of the tins are labeled, but it is known that 8 contains soup, that is represented by S, 4 contains beans represented by B, and 3 contains peas represented by P. If 7 tins are randomly selected without replacement, find the probability that exactly 5 of them contains soup. So find the probability. So probabilities formula is favorable outcomes over total outcomes. So it is conditional that we have to select. Okay, the condition is if 5 tins are randomly selected without replacement, find the probability that exactly 5 of them. So this is the condition, exactly 5 of them have to be selected, that is soup. So look now, we have to select from the 8 soup tins, 5 should be soup tins, and 4 beans and 3 peas are irrelevant. So out of 7, we have to select any 2. So look now, we will represent this 8s because 8 soup tins are there, and 4 and 3 other than the soup are there. So 7s complement. So S complement represents not soup. Okay, 8c5, because we have to select 5 soup tins out of the 8, and definitely 2 will be left. So 2 out of the 7 tins will be selected. So this is the favorable combinations. and over total favorable total combinations. So in total there are 15, and we are going to select 17. So 15C5 possible combinations. So favorable outcomes over total outcomes. So when you will solve it on the calculator, this will give you the answer. This is the answer. Here is another very important question. A girl has a bag containing 13 red cherries and 7 black cherries. She takes 5 cherries from the bag at random. Find the probability that she takes more red cherries than black cherries. So in this case, again, we have to make possible makeups. Here are red cherries and here are black cherries. So 5 cherries are to be selected. So suppose all 5 cherries are selected, and then definitely we have to select no black cherry. So 13C5 into 7C0 will be the first case in which more red cherries are selected. Then second case is when 4 red cherries are selected. So definitely one black cherry should be selected. So 13C4 into 7C1. So this is the answer. And the last possible option in which more red cherries can be selected is 3 red cherries are selected and 2 black cherries are selected. So 13C3 into 7C2. So this will be the answer. And the final answer, favorable outcomes are adding all 3 answers. So this is the favorable outcome. Because we are going to find the probability. So favorable outcomes over total outcomes. So in total there are 20 cherries in the bag, out of which 5 cherries are to be selected. So 20C5 is the total outcomes. So this is the answer of the total outcomes. So favorable outcomes over total outcomes is the answer. Here is another very important question. A minibus has seats for the driver and 7 passengers. So driver is represented by D. So it is driver's seat and 7 passenger seats are here. Okay, when 7 passengers are seated in random order, find the probability that 2 particular passengers A and B are sitting on a part, the same side of the minibus. So when it is conditioned that A and B are to be seated on the same side of the minibus, so they can be seated on driver's side or on the other side of the driver. So this is the possible option, on the driver's sides or on the other side of the driver. So look now, if they are to be seated on the driver's side, so A and B both sitting on the driver's side, so there are 3 possible options. So 3P2. So this is the number of the ways in which they can be seated on the driver's side. So, or if they are to be seated on the other side of the driver, so A and B both not sitting on the driver's side, so there are 4 options. So 1, 2, 3, 4. So 4P2 is the number of the ways in which A and B can be seated both on the same side, that is on the other side of the driver. Okay, and in total there are 7 possible options, out of which these 2 have to be seated. So 7P2, A and B sitting in any 2 of the 7 seats. So look now, P on the same side, that is probability on the same side, is equal to probability both on the driver's side, or stands for plus, probability both not on the driver's side. So 3P2 over 7P2, favorable outcomes over total outcomes, or another choice is here, that is not on the driver's side. So 4P2 over, like, favorable outcomes over total outcomes. So here is the favorable outcome over total outcome. So when you will solve it on the calculator, this will be the answer. B part is, that will be simpler now, opposite side of the minibus. So we have get the answer when the both A and B are on the same side. So if we subtract the answer of A part from 1, we will get the answer when A and B will be on the opposite side of the minibus. So 1 minus 3 by 7 will be the answer of B part. That is probability on the opposite side. So 1 minus probability of the same side, that is 1 minus 3 by 7, will give you the answer 4 by 7.